Welcome to the lecture series on solving previous year questions of GATE ECE, and we were solving the questions related to digital design, and this is the part 2. So this is the first questions, this is from GATE 2024. The question is, for a Boolean function f of a, b, c, d equal to sum of minterms, that is 0, 2, 5, 7, 8, 10, 12, 13, 14 and 15. The essential prime implicants are, so we need to find the essential prime implicants. Okay, so what we will do, we will draw the K map of this function. Yeah, so this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Here a, b, c, d, and this is the function. Okay, and we know this is correspond to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? We have 0, 2, then 5, 7, 8, 10, 12, 13, 14 and 15. So we'll start clubbing. So we can club these terms. Okay, and we can club this too, these 4 terms, fine. And we can also club these 2 terms, right? So if you see this and this, we can club in 2 ways. Okay, so one is I can club like this, or I can club like this, right? Which means, so what we'll do, I'll write the minterms or implicants corresponding to these clubs, right? So for this middle one, what is the term? The term is like here, a will be cancelled, so b will be remaining. So b, and here only d will be remaining. So b, d corresponding to the this implicant, right? Or so this is the implicant corresponding to this group. Okay, and what about this group, the cornered group? So here b bar will be there, and in this case we have d bar. So we have b bar and d bar. Okay, and for this, the other 2 groups, for this group I have a, okay, a and d bar, and for this group I have ab. So the function will contain bd plus b bar d bar plus ab, or I can write bd plus b bar d bar plus ad bar. So corresponding to which of these 2 I am selecting, I can get these 2 terms. But so if you carefully see here, only these 2 terms bd and bd bar remains same, right? So these 2 forms the prime implicants. So the answer is A. Okay, now coming to the second question. It is again from GATE 2024. A 4-bit priority encoder has inputs D3, D2, D1 and D0 in descending order of priority. The 2-bit output AB is generated as 00, 01, 10, 11, corresponding to the inputs D3, D2, D1 and D0 respectively. The Boolean expression of the output bit B is, okay, so the question is, a priority encoder has been given. So input of the priority encoder is D3, D2, D1 and D0, okay, and output is AB. Okay, so in the question it is given, it is a priority encoder, right, and the priority is more for D3. So when D3 is 1, Okay, D3 is 1, the output AB is actually 0 0. So what about D2 D1 D0? Whatever is the value of D2 D1 D0, if D3 is 1, the AB will be equal to 0 0, right? So we don't care what is the value of D3 D1, sorry, D2 D1 and D0. Okay, similarly when D2 is high and D3, so D3 is 0, so 0 1. Okay, and whatever the value of D1 and D0, the value of AB will be 0 1, right? So 0 1. Similarly for 0 0 1 0, that is when D1 is 1. Okay, and D3 D2 is 0, and sorry, this is don't care, yeah, and D0 is don't care. Then AB will be 1 0, and when it is 0 0 0 1, the AB will be 1 1, right? When D0 is 1 and all other are 0. Okay, and there is one more case, right? When 0 0 0 0, at that time we can consider AB as don't care. Okay, so this is what the given question. So what we have to find, what is the value of B? Okay, Boolean expression of B. So how we will find? We can draw the K map here. So okay, D3 D2 D1 D0. Okay, this is corresponding to B. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0, right? So so here when does B become 1? So for this case, that is when D3 D2 is like 0 1 and D1 D0 is don't care. So D3 D2 is 0 1, and for whatever value of D1 D0, so for all these cases the output B will be 1. Okay, and when for this case, that is when D3 D2 D1 D0 is 0 0 0 1, so 0 0 0 1 for this case also. And for the case 0 0 0 0, the B's don't care. So in this case it is don't care. Okay, so we can club this. So if I club this, it will be, I can club like this and like this. Okay, so what will be B here? So this, if I club this, this corresponds to D3 bar D2, and for the this clubbing we'll get it as plus D3 bar D2 will go, and D1, right? D3 bar plus D1. Okay, sorry, D1 bar, sorry, D3 bar plus D1 bar. Okay, so the answer is B. Okay, so let us see the next question. This is from GATE 2024. So this third question. This is from GATE 2024. The propagation delay of the 2:1 mux shown in the circuit is 10 nanosecond. Consider the propagation delay of the inverter as 0 nanosecond. So this 2:1 mux has 10 nanosecond delay, and this inverter has 0 nanosecond delay. Okay, and if S is set to 1, then output Y is, so given S is equal to 1. So if S is 1, whatever is the value here, it will reach the output Y, right? So this will propagate and we will get at Y. Okay, so we'll see here. So say let initially say this is Y. Okay, this corresponds to Y. So initially let Y equal to 0. Okay, so initially let Y is 0. Okay, and we'll start from this point. Okay, so S is 1 and Y is 0. So if Y is 0, this input to NOT gate is 0, so output of NOT gate is 1 now. Okay, so when this is 1, and is there any delay here? The delay is 0 nanosecond. So at the instant when 0 comes here, the output of this NOT gate will be 1, and that will be the input of mux. Okay, now if the value input to this mux is 1, what happens to the output? Output will go to output will be now 1. Okay, and this happens only after 10 nanosecond. Okay, so at this time, okay, at this time I have set S equal to 1, and input y was equal to 0, and at this instant what happens after this instant, right? So after 10 nanosecond delay, okay, after this 10 nanosecond delay, the output y will go to 1. Okay, so when this output is 1, what happens now, right? Now the input to this inverter is 1, at the same instant the output of the NOT gate is 0. Okay, so this input is now 0, so what happens, this 0 will now propagate to y, so this 1 will change to now 0. Okay, and when does that happen? After 10 nanosecond delay. Okay, so after 10 nanosecond delay the output will go to 0 or change to 0. Okay, so again when this happens, the output becomes 0, so the input to inverter is now 0, output of inverter is 1 with 0 nanosecond delay, and now this 1 will be propagating to the output after 10 nanosecond, right? So after 10 nanosecond the 0 again becomes 1. Okay, so after 10 nanosecond it will become 1, and this will repeat. Okay, so if you see here, what's the total time period? This is 10 plus 10, that is 20 nanosecond. Okay, so what is the frequency here? F equal to 1 by 20 nanosecond. Okay, or I can say 10 power 9 by 20, right? Or 1000 into 10 power 6 by 20. So this is 5 megahertz. Sorry, this is not 5, this is 50. Sorry, 50 megahertz. Okay, 100 by 2 is 50 megahertz. So answer is B. Okay. The fourth question, this is from GATE 2024. The sequence of states Q1 Q0 of the given synchronous sequential circuit is. Okay, so we'll see how the output Q1 and Q0 varies. So let the output of the flip-flop 1 and 2 be 1 initially. Okay, I can take it as 0 also, so let it be 1. Okay, so if it is 1, so I'll write here Q1 and Q0 is now 1 1. Okay, so if it is 1, what happens? The input to this OR gate is 1, so 1 and 1 is 1, or 1 is 1 here. Okay, and since this is 1, I will have the input, this input to this OR gate as 1, and since this is 1, Q0 bar is 0, right? So Q0 bar is 0 means this is 0, 1 or 0 is here 1. Okay, so what happens in the next clock cycle, since the input to this T flip-flop, okay, is 1, okay, the output of this T flip-flop will toggle. Okay, so what happens? The output Q1 will become now 0. Okay, and Q0 also will become 0, because 1 to 0 it will toggle. Okay, so now the output Q1 and Q0 is now 0 0. Okay, so I'll just clear all the other values. Okay, so now it becomes 0 0. So since this is 0, here the input to this OR gate is 0, so 0 or 0, this is 0. Okay, since Q1 is 0, the input of this OR gate is 0, and also since Q0 is 0, Q0 bar will be 1, so input to this OR gate is 1, so 0 or 1 is 1. Okay, now if you see the input T0 is 0 now, so what happens? The previous output will remain at the output of the T flip-flop, right? So the next output will be now 0 itself. But what happens here? The input to the first flip-flop is 1, so the output of the first flip-flop will toggle now. So this will change to 1 now, right? This will change to 1, so it will toggle. So the next output is 1 0 1 0. Okay, so I will clear the other values now. Okay, so now it is 1 and 0. Okay, so if it is 1 and 0, Q0 is 0, so here 0, 1 or 0 is 1. Okay, and what happens, q1 is 1, so here OR gate is 1 and q0 bar is 1, so 1 is here, and so the output of this OR gate will be 1. Okay, now what happens, we'll see here. First, since the input of this flip flop, okay, second flip flop is 1, okay, the output of this flip flop will toggle, right? It will change from 0 to, it will change to 1 now. Okay, and what happens here, also input is 1, so the output of this first flip flop will toggle, it will change to 0. Okay, so the next output is q1 will be 0, okay, q0 will be 1. Okay, so I will remove the other value, so it is 0 1. Okay, so 0 1 means, so let me write here. Okay, so since q0 is 1, this input is 1 now, so 1 or 0, this will become 1, so this is 0. Okay, q0 bar is 0, so this is 0 and this is 1, so here OR gate is, output is 1. Oh, sorry. So this is 0, right? Sorry. So this is 0 now. Okay, q1 is 0, so this is 0, so this will be 0, right? So what happens, since input of first flip flop, this flip flop, second flip flop is 1, that is t0 is 1, the output of this flip flop will toggle to 0, right, or change to 0. Okay, and what happens here, input is 0, right? So whatever was the previous input, that will remain, that is 0, so output will be 0 0. Fine, yeah, and this will continue. Now from here it will continue, okay, from here again. So what is the transition, first it is 1 1, second is 0 0, then 1 0 0 1 1 0 0. Okay, this you can see in the option B. Okay, yeah, so that is the answer. Okay, that's all for today. Thank you.